Well, hello again, stargazers, and welcome to our Astro Hour. It's number 282 of the SBAU Astro Hour. It's all for our club, the Santa Barbara Astronomical Unit. It's our weekly effort at educating the members and the rest of the world who want to tune in anyway on the latest updates in astrophysics, the entire heavenly scope of cutting edge cosmology. It's a big universe out there. We're live from our living rooms or private dens, meeting on screen through Zoom every Monday morning for our YouTube channel and this incredible summertime week of July 20th through the 26th. According to the talking points, we got the same moon we had back in July 20th of 69, about the time they launched Apollo 11. We're all well into our sixth year of doing this. The Astro Hour is free to everybody, and it's our president. And in 2 weeks, introducing you. We'll
Morning,
talk to him
Tom.
in a minute. Yep, everybody. We're at the Museum of Natural History, first Friday of every month, and it'll be Jerry Wilson's take on new planetary excursions out in space, exoplanets, something we talked about recently here. Then we're going to assemble for our second Saturday star party for August. May the force be with you. As we said, the moon's in the first quarter. We're going to talk about a couple of comets this week. One of them, we're going through its path, the Swift Tuttle. It's the Perseids and friends for this week's meteor shower. And then there's a comet named Tempel closing in on the moon. We had a 10-year hide and seek exoplanet out there that we finally found. And we finally won that little back and forth. Orbiting the star Beta Pictoris is a lot of stuff, boy. Going to visit an H2 region emission called Tulip. It's a nebula out in Cygnus, which is a neighbor to a black hole. And what's the deal on colors of celestial stuff? It's mostly in our telescope filters. So let's meet the gang, shall we, that runs the show. This is our beloved president, man with a doctorate and an entourage and a beautiful wife named Pat and Jerry Wilson. Good morning.
Good morning, and good morning to my sister Joyce and my two grandkids, Riley and Calvin.
That's right,
And,
off-screen
and
kid.
my
Can't
wife,
see it, but
Pat.
there's a peanut gallery there, right? Just like Howdy Doody used to have. They're in it. Nice
Right
lady,
now,
Pat.
we have a construction crew remodeling our bathroom. Pat is in a hospital bed and the downstairs recovering from abdominal surgery.
Oh,
Workers are going back and forth. The front door's open, and the cleaning lady is about to arrive.
Well, we need one more report from you.
I'm in here with the cat.
That is going to be my last question. What's the status on the cats? Here is our outreach captain, Chuck McPartland, in front of the green flag. Looks like that flag's going to be up behind him a long time. He's married to a Pat, who's our treasurer and merchandise manager. One of those two headings we'd like to get rid of probably in time. The lens expert and future science orator Tim Crawford has joined us, married to Karen. Tim is a shy, quiet, hard to get him speaking, but we're going to put him up in front of us in December.
get well, Pat.
Yeah. Married
She's
to
doing
Karen.
great.
Tom
Give Pat our best, Jerry.
Say again?
Is it tell Pat to give her our best, okay, Jerry?
Yeah.
Yeah, absolutely.
Yeah, this is the first we heard about that. My God.
Well, she's walking around. She just can't do stairs.
Okay. A lot of stuff happens at our age. Here's a man who's hanging in there pretty well. Bird watching, bread making, Tom Whittemore, retired Westmont science teacher.
Hi, guys.
You have dreams about that lab? You must. You were in there. You were in there.
Not the lab. When I have dreams, it's usually the faculty I knew and liked. Usually that. Especially Ken Kilstrom.
You were holding court out there at
Remember Ken.
Westmont during many years. You were still editing our paper, weren't you? Our newsletter.
Yeah. Oh, yeah. No, I think I started doing the paper, Chuck, 2004.
That's about right.
Yeah. So
And when did you retire?
yesterday we talked 92 people to walk into the Palmer Observatory, but among them were two professors from Westmont. It was really nice to meet them.
Really?
Women. Yeah, women professors, different department that I was in. But I didn't really know them. They knew Mike Summerman, Ken Killstrom, Warren Rogers. So it was nice little chumming up.
We get a
I
lot of
missed
those
that, Tom.
guys. We get a lot of those professors from all of our universities and
Well, yeah,
colleges.
a few weeks ago, we got a husband and wife pair from UCSB, both astrophysicists.
I know one of them. I
Yeah.
had her booked for September October 2nd.
Oh.
Her name was Caitlin Casey,
Okay.
and they came
And
from
you know,
Austin.
Tim was trying to get you guys an image from his little telescope on the sun, but I don't think it happened, right, Tim?
Oh, it did, but it's not. It's
It's not good enough.
He showed
I
it
can
to
work
us
on it.
before we went on the air.
What's it look like? A splash?
It's very, very red, but I have one of the prominences, a filament showing, and that
Yeah.
little knot at the top that came out.
Yeah, it's very
Before-
promising.
Really?
That's
Yeah.
neat. That's neat. Yeah, because yesterday Tim's prominence on the top was a goatee on the bottom for me.
Well, we don't have the night sky posted in Jerry's talking points, but I have a feeling we're going to go there pretty quick. So your wife, Maureen, she's doing okay?
Yeah, sure. Mhm.
All right, gents, then let's go to the silly stuff because science can be funny. Jerry's forwarded silly science cartoons. We got 6 of them. There may be some new ones and surprises amidst them. So we enlarge that. And
I like this one.
all right, then you tell us about it. What are we looking at? It's a control tower, obviously.
At first I couldn't understand this. And the guy turns to he's in the control tower, and he turns to his companion there, and he goes, "Boy, look at the size of this blip." And
That's right.
I didn't get it at first, but it's that plane coming through the window.
Right. And its landing gear, Tim, are still down.
Well, it was trying to land or take off. He's about to have a close encounter of the fourth kind.
Yeah, he's about to land.
Oh, this is one of the bizarro ones. I
Yeah.
didn't notice that. Yeah, there's the little K2 and the eyeball.
Yeah,
This-
but no pipe and no dynamite.
But
and-
is that anything? That's a piece of pie.
Crazy.
I'm
I think
wondering if
that's just
that
a
isn't
little
a
wing.
dynamite right there.
At the size of the blip. You suppose they'd get bigger on it? Never mind, I guess. Okay, Jerry, that was a good one. Go to the next one.
Yeah, that's good
This
too.
is our mobile running rickshaw and a little piece of physics. Jerry, want to explain this to us?
Yeah, actually, this is I learned this a while ago. These things that were carried by people that you ride in are called a fancy. And
Oh, what?
people refer to if they see someone they like in a passing fancy. That's where the
Ah.
phrase came from. It was
Oh.
just.
Oh, I'll be darned.
But anyway,
Okay.
here he's challenging Newton's laws
Yeah.
by holding up. The guy trips and falls, so the king reaches out and holds it up.
They all had those, huh? Precursor to the stagecoach.
Hmm.
Okay.
A passing fancy. That's good.
All right. How about Mr. McPartland? You want to explain this?
Okay, here's Luke Skywalker, and the text says, admit it, at least one time in your life, you seriously tried to move an object using the Force.
The Force
Yeah,
wasn't
guilty on
with
that.
you. He lost his hand, didn't he? One of the last ones. Okay, Tom, what more? Where are we here? Is this one of your nightmares?
Yeah, it looks pretty good. I think I prefer it down here with you. And it's all about the news, I think, right?
Yeah, and he's down
Okay.
there with the monster under the bed.
The boogeyman. That's the boogeyman.
Yeah.
We all had them, didn't we? Okay, we have a fun fact from President Jerry.
We have never found a cave painting of a salad.
Right.
I guess you're right. Doggone it. Gazelle steak, that's something different. All right, how about Chuck McPartland explaining the bird problems of today?
Okay, 2 neighboring nests, and one chick is looking at another one. One of them's got a virtual glasses on and is piloting a little joystick, and the other chick is being told by its mom, I don't care if your friend has a flight simulator, you're going to learn to fly on your own.
Those nature documentaries, got to update them. Okay, we're off and running for another week here with no end in sight. I got a feeling you're going to take us to the night sky pretty quick, even though you didn't put it in the talking points, Chair. That's in the night sky, isn't it? That's a
Yes,
quarter. That's not a half. That's a quarter.
that's the first quarter moon.
Because when that doubles in size, it'll become a full moon.
That's right.
It doesn't go up.
It's 1/4 of the way through its phases. That's
Yeah.
where the name comes
We
from.
totally understand, but it defies math a little bit.
So trivia question for Ron.
I'm the guy.
Chuck, don't help him. The
Okay.
sun really right now is in Gemini. Okay. It's not really in Cancer, it's in Gemini. So what constellation would a first quarter moon be in?
Which it is now. So what
This is
constellation?
a pun alert. I
Just roughly.
Cygnus the Swan.
That's not a zodiac constellation.
Oh, you're right. It isn't. I've been telling
Okay,
people all my life.
Here's another way to put it.
Okay.
How many zodiacal constellations would you have to count through to get the first quarter moon away from Mr. Sun?
How many constellations? 12?
How about 12 divided by 4? What's that?
3.
Okay, so count backwards 3 constellations roughly from Gemini.
Oh God, is it? Let's see, Capricorn,
Cancer,
Cancer.
Leo, Virgo. So it must be roughly in Virgo, right, Chuck?
Sounds good to me.
Yeah.
It was in Leo the other night, so
Yeah. Okay.
hopped one over.
There you go.
Virgo means virgin.
Yes.
Whoa, it's
Yeah.
very sexy out there in the sky. All right, I'll take your word for that. I learned something. Thanks, Tom.
Yeah.
Jerry.
This was posted on the astronomy website, and it says the lunar phase here is exactly the same as it was on July 20, 1969.
Wow.
And as you know, on July 19, 1969, Armstrong took his step on the moon.
Right. And I understand he was from Purdue University.
Okay.
And as I told my friends when we first signed on, PBS is rerunning the whole thing.
Yeah.
50,
I'll never
60 years.
forget that. I'll never forget that. It's amazing.
I mean, it's got Walter Cronkite and the blast off, which I wonder if they're going to last 4 days because that's how long it took to get there.
Mhm.
Huh. Okay.
And the landing site was visible in the image.
So they wouldn't send them on a full moon. They'd send them on a quarter moon yeah.
They sent them near the terminator of a quarter moon because they wanted the maximum time in sunlight possible.
Okay.
Oh, I see. It was
They
bright.
landed at dawn on moon time.
Yeah. But if you can see the soccer player there, it's in his shoulder. There's a little thing there. Come down. Right there. That's where they landed. There's a little fish shaped feature with a Pac-Man mouth, and he's grabbing a little white cookie. And that little white cookie is Moltka. That's a little crater, and they were landed pretty close to that.
Wow.
Where's this
like
fish?
that guy Messi from
Is that a fish mouth, or that's the fish?
I think
That's the fin, yeah, and then there's a fish mouth and a little cookie above it.
Oh, okay.
that's pretty good.
Yeah. Good eye. I didn't see that.
that's where we're looking at Apollo 11 site.
Yes.
Yeah.
And there's not a telescope on Earth that can see it, right?
That's right.
Someday that'll be Armstrong City.
Yeah.
Now we're coming up on a period of, as I was able to capture it on the internet, 3 meteor showers, starting with the Perseus, and the radiant is in Perseus. And this shows a past composite image of Perseid meteor showers from July. Well, that's when it's going to happen. From July 17, which was a few days ago, to August 24.
Peak around the 12th.
Yeah.
And it comes from the Perseid radiant.
Yes.
But the comet was Swift-Tuttle.
Yes.
Yes, it was.
And when was that? When did Swift Tuttle leave that path? Do they know?
Over thousands of years.
Yeah,
Oh,
it's not
okay.
not an instantaneous burst.
Well, also in that picture was the Andromeda Galaxy.
That's right.
Really?
See it?
Up near the top.
I see the Pleiades,
I
Yeah.
see it.
and
I
there's
know I see
Andromeda.
our galaxy, right?
Yeah.
Yeah,
And our
right.
galaxy.
And the Great Rift.
Yeah.
Mhm.
Wow. But what are the friends you refer to in your talking points?
The two other meteor showers,
Oh,
Perseids and two other meteor showers. The other one is the Southern Delta Aquariids and the Alpha Capricornids, which is July to mid-August. These are minor meteor showers. They're not as big or as headline news as the Perseids.
but we're going to see them in different parts of the sky.
Yeah, they're named after the radiant where they are in the sky. Unfortunately, they will all peak under the buck moon on July 30 to 31st, which is a full moon, which is a week away.
Hmm.
A little over a week away.
You can see some green in one of these trails, and that's, I think, nickel.
Wow.
Really?
Well, there's some green here, and there's some real
There's a
vivid.
good green, yeah.
People
And
can
there's
be
some
allergic
here
to nickel.
too. I don't know if the colors are the same for you as on my monitor, but most of these things have a green start to them.
Yeah, they do on mine.
Nickel, huh? Are we running out of nickel like we are copper?
No.
No,
But copper is becoming valuable and rare.
we don't really run out of things. What the easy to get at stuff we're running out of. We just have to dig deeper.
Okay, all the gold is in the middle.
I just checked, and our star party at the museum is the 15th. So we'll be 3 days past
The main peak.
the
Yeah.
main peak. So there we may get a few that night.
Well, mostly you get them in the morning, as you know.
Oh no, I didn't know that.
Yeah.
After midnight's always best. Then you're on the leading edge of the Earth.
Okay.
Okay. This is the path of the Earth's orbit around the sun. And during this Perseid meteor shower, you see the Earth here is passing right through the orbital debris of Comet Tuttle-Swift.
The debris is totally wiped out. It washed out. Yeah.
Okay. Okay.
Can you tell me more about Tuttle Swift? Does it still come around?
Yes.
Yes.
How often?
Ooh, it's
80 years like Haley?
in that neighborhood, like Halley's Comet. Yeah.
And so whoever found it, their names were Tuttle and Swift, the two
Yeah.
astronomers.
Swift and Tuttle. Yeah.
Got it. Wonder when that happened.
There it is.
Ah,
Okay, so
ta-da.
here's the Earth in its orbit around the sun, and here's the debris trail from Comet Tuttle-Swift, and the Earth is right here, not to scale, by the way,
Yeah.
just right here, and the comet is out here.
And you can see we hit it in August. And then we hit it again.
Oh yeah, we hit it
Potentially.
right here.
Yeah.
Well, it's not August yet, but we hit it here, and then we'll hit it out here about 6 months later for us.
But it won't be as we're hitting a different part, not necessarily in the central part of it.
Right.
Well, gentlemen, this may be a reaffirmation of a former question, but I need clarification. A comet would be defined as something with gas in it that leaves a tail and goes around the sun.
Or
If
debris, little pebbles and dust and gas and stuff.
Okay, but an asteroid that didn't have anything to make a tail might do the same thing. We just don't call it a comet, and you'd never see the tail.
It's fuzzy, just like everything, Ron. So the Geminid shower that we get in December is from an asteroid, what we were calling an asteroid. but it goes really close to the sun and spalls off rocks.
Yeah.
And so that's what we see.
There's the famous incident, I guess you could call it, a few months ago or now a year or more ago, about someone looking at his monitor as they were monitoring or flying by an asteroid. And he noticed that the star pattern in the background of the asteroid was changing far too quickly to be real. And then they realized that what they were viewing were little pebbles and dust grains that were being thrown off of this asteroid body. So it was contributing to its own orbital debris trail there, but it doesn't have a visible trail to the earthbound instruments because it's not giving off white cloudy vapor. So it'll just give off little pebbles and grains and stuff.
Well,
So
I'm imagining,
in
gentlemen, this
support of
massive.
Chuck's fuzzy border.
Pardon me for interrupting. I was just curious about billions of years ago when our solar system first became solvent. We got our oceans from these suckers, didn't we? But there's far less nowadays. In fact, Venus got its share of water, and Mars supposedly had water. We got to keep ours. And so they must have had comets like crazy, or I say they, 400 billion years ago. It was nothing but comets with water on
Well,
one.
it's Ron, it's still fuzzy. It's comets and meteorites both contain water.
Yeah. And the Earth contained water from when it formed in the form of minerals and liquid, just because they were some of the ice that later became water on Earth were some of the chunks that got drug in by gravity.
Well, that
So
was
water is extremely common in the universe.
and most of your bodies out there have it in it, have heart frozen, I'm sure.
Or just captured in minerals.
Yeah.
Hmm.
Okay, now we're going to go to a very interesting exoplanet out here in Pictoris. I forgot what Pictoris is supposed to be, but you'll agree it is well represented by this bent line.
Pictor, I think, is something like an artist's studio.
Okay. Anyway, this is something you're not going to see from our latitude in the north. This is Canopus, which is a son of a southern star. And this is the star Beta Pictoris, which is actually a binary star. Let's see, where are we? Okay. And it's in the south. See, the Large Magellanic Cloud is down here.
Oh,
And this is a photograph
Wow.
taken by Hubble of Beta Pictoris with a large blot of the star blanked out here because it would overwhelm the image because it's much, much brighter than this, than the disk it sees. Now, the disk we see is almost completely edge on.
Accretion disk?
It
Yes.
is an accretion disk, but it is not, it's more of a past the accretion stage, let's put it that way.
Okay, and are we talking about exoplanets here?
Yes, we're talking about an exoplanet. This is the Beta Pictoris system, and this is the size of Neptune's orbit. This is where Beta Pictoris is, and this is a double star going around it, Beta Pictoris B and D.
Well,
B and D?
those are the two planets.
Yeah, those are the, excuse me, yes, this are the two
Yeah.
planets, yes.
Oh, but it's not a binary star system. It's one star.
But we'll get to that.
Oh, okay.
So, yeah, I had a movie, but it's too long to load. So this is a picture by the European Southern Observatory. Shows Beta Pictoris B. Yes, Chuck is right. Beta Pictoris A is, of course, the star. So that's right here at the core. And this is Beta Pictoris B. And there is also a D in here. Debris disk is out like this.
And it's a single star. It's not a double system.
Okay.
Yeah.
I'm
Yeah,
imagining I
the
could.
mass of Beta Pictoris D is around 2.5 times the mass of the Jupiter.
So it's a gas
And
giant.
what are the other facts here? Okay. So they've been checking to see this. People see it and then don't see it. So it took them, 10 years to identify, finally confirm the identity of Beta Pictoris D. It's
Holy
100
cow.
times fainter than its sibling Beta Pictoris B, which is another planet in the system, the first planet discovered in the system.
10 years. Good
Beta
grief.
Pictoris D is the faintest exoplanet ever seen from Earth.
So the one that was small and hidden is an inner rocky, what compared to the other one, which is a Jupiter-sized gas.
These are various instruments looking at it. This is from James Webb Space Telescope, the NIRCam in 2025, NIRCam in 2023, the Very Large Telescope in 2025, the Sphere, which we discussed before, the telescope down here, and
Ronnie, B is even bigger than D. It's also a gas giant.
yes. And they've also seen now a fainter second disk tipped with respect to the first, which is not obvious in this picture, but you can see a faint fuzz there.
Oh, yeah. Yeah.
Yeah, but the most interesting thing about this stuff is, whoops.
Yeah, I didn't notice that.
Oh, I got to change back. This thinks it's the end of my presentation.
Get a what?
Be
Yeah.
patient.
Can't just follow your. We have a long track on our screen called your talking points. I just think you'd cruise down that.
Well, when he cruises down through the Word document, it messes with the contrast levels in the images.
Oh, is that what happened?
Yeah, it's Microsoft helping you out.
Yeah. Now, this is a picture of Beta Pictoris here. This is the most interesting part for me of this whole presentation. This is Beta Pictoris, and this is the dust lanes, or the
The
disc.
disc.
disk. And this is taken through a 10-inch Newtonian.
Good grief.
And what they did, this guy read an article published a decade ago or something. Let's see.
How did he block it? Or is that the B?
No.
Is that
That's exactly where we're going. Good question there.
And you got to arrange your diffraction spikes just right.
Yes. Let's see. Okay. This was taken by an amateur astronomer named Rolf Olsen in New Zealand using a 10-inch Newtonian reflector and a modified webcam. It's based on a technique published by Le Cavalier des Étangs in 1993, which he explains how to block the core of the sun. And the technique is that you take, let's see if I got that coming up. No. Okay, what you do is you take a picture of, God, I thought I had that.
The big black ball in the center is his filter, right?
No, you would, in a big scope with a lot of expensive equipment, you'd expect that to be an occulting disc. I guess I left that sentence out. I can't display it, so I'll explain it. Next to Beta Pictoris B, or Beta Pictoris, there is another star, Alpha Pictoris, that's a similar distance away, and you take a picture of a similar star, similar brightness, a similar distance away, and you take a picture of that and you make a mask out of it. And then you take a picture of this, which is Beta Pictoris, and then you subtract the two images from each other with a few little caveats. And this is that image with an equivalent star subtracted from it. So what you see is the difference between the two of them. But somehow you've got to make the picture of the star that you're using as the occulting disk, you got to make that picture taken under exactly the same conditions as you took this picture of Beta Pictoris. And so he goes through a process of estimating from the magnitude difference, which is a known quantity. He can estimate the brightness difference between the two stars. And then he calculates the exposure time to give the stars a similar appearance. And then he goes through a program where he subtracts one from the other. And this is the resulting image. Very clever process, very nicely done. And I explained the whole picture or the whole process really in the talking points, which of course I'm not displaying here. But it was from, and he was collaborating with a guy named Dr. Grant Christie of Auckland's Star Dorm Observatory that helped them expose the picture right.
Was that to put all the to put the scales in the image and all that? I mean, that had to be time
that's
consuming.
all post image.
Yeah, but
That
it's a lot of time consumed doing all this.
Yeah, when you process astro images like this, it can be a very time consuming process.
Yeah.
It takes me about 6 to 8 hours to process a single image. But
Whew.
there is software out there for every level of amateur interest. I took a class from Adam Block in 2009, and we went through a process that is 100% manual. You go through each step, you do all the settings yourself, you look at things, and you compensate the signal you don't want, you compensate for noise, and you do all these things. Now you have a wide range of software that will do it or attempt to do it all automatically. You don't have to do any of this stuff. As a matter of fact, I get derided from doing it the old-fashioned way. I don't have to beat myself up like that. But
Well, I don't know, Jerry. A lot of these guys admire what you do.
well, okay. So thanks. So anyway, and this is from a TOU cam, not even an Astro Imager camera, but just the one that's sitting on the top of your monitor staring at you right now.
Yeah.
I thought that was a bird.
Good. Thank you, Captain Pun.
Yeah.
There's no way this guy could get the two exoplanets. So
Thanks, Tim. Yeah, two can play this game.
Yes.
Two cam tango.
Yeah.
So anyway, this is a collection of
Thanks, Chuck.
44 images of Beta Pictoris at 7 seconds each, and 299 images of Alpha Pictoris at 4 seconds each.
Good grief.
Both sets of images were dark subtracted and stacked separately in Registax, which is a free software that does it sort of a semi-manual thing. Rolf then subtracted the alpha image from the beta's image in PixInsight Light Edition LE, and also created the absolute difference between the two of them.
So I used PixInsight, really.
And Tim,
Yeah.
just think this guy could have been looking at the moon with a wide field refractor.
He could have been.
Yeah.
Now
Well,
this is photometry of his image. Very sensitive, calibrated for brightness. And this is a 3D map of the brightness of his final image. And you can see the obvious image from the disk. And this is background signal. It's called fixed pattern noise. It is not noise in the sense that Pluto is not a planet, it's a dwarf planet. So this is not noise, this is fixed pattern noise. The reason that it's called fixed pattern noise is it doesn't change with time. And the definition of noise is that it's a temporally stochastic, that is, it fluctuates in time. If this were real noise, it would be pulsing up and down and wriggling, but it's not.
And Tim, this looks like a candidate for surgery, doesn't it?
Yeah. This actually gave me a pause for a moment because a guy asked me a question about my solar scope yesterday. And
Uh-huh.
this left image is, I'm going to bring, if we have time at the end, I'm going to ask that question. So
Okay,
go ahead, Jerry.
that's it.
Okay.
Now, getting away from the constellation of Pun, we have a black hole,
Uh-oh.
Ooh,
and the const and the
It's
what
not
is
just any black hole.
yeah, we have the black hole and not the center of our universe, our galaxy, but the closest one to us. It is the black hole and the Tulip nebula.
Is that SIG-X1, Chuck?
Yeah.
Yes, yes, it's X1.
University of Arizona.
Cygnus.
First black hole.
Yeah.
U of A.
So
I
here we are
didn't
in
know that.
Cygnus. This is at midnight. It's up, not quite overhead, but it's high enough that you can get a good shot of it.
Is the Tulip Nebula something we can see with a home scope?
The two nebula,
The
Tulip.
Tulip?
Tulip. Oh, the Tulip nebula. Hang on to that. You'll see in a minute.
Okay.
This is a picture of that region.
Yeah. Wow, that's pretty.
This is Eta Cygni. This is the Tulip Nebula here.
Okay.
This is the Crescent Nebula.
Mhm.
M29, Gamma Cygni Nebula. And
Wow.
this is Solder.
Mhm.
So it's in the right neighborhood. A lot of structure here, a lot of dark nebula. This is one branch of the Milky Way here in the sky. This is a picture of the Tulip Nebula. This is the tulip. It's shaped like this. Looks
Pretty.
like head of a tulip. A few dark lanes in it. And this is a combination of the Tulip Nebula created by putting H alpha in the red channel and O3 filter in the green and blue channels in an Orion 80T CF. So this is an 80 millimeter scope. It's a small wide angle telescope.
Oh, yeah.
And ZWO ASI 1600 mm. So that's not a color camera. It's a wide field camera in black and white. So they took several images. And by Chuck Ayob, I don't know where he's located, but I guess we can figure that out. Now this is the Tulip Nebula over here. And this is a shock wave,
Wow.
a bow wave created by the jet of material being shot out along the axis of Cygnus X1, which is a black hole right here. And this is a companion star, which I can't find the name of right off here. But anyway.
Is that central star? That's a accretion disk right there?
This,
No. The bottom star of those two is the Cygnus X1 binary system.
right.
That's just like a background or foreground star,
Okay.
that other one.
Well, my understanding, gentlemen, of a black hole is that nothing can leave it. It gets sucked in. How come it's being thrown out?
Because it can't swallow it. There's a limit to how fast it can swallow stuff.
So that big bow shock is jillions of AUs away.
Yeah, this is the double star that contains X1, not this.
Yeah.
As Chuck says. So it's shooting out stuff like this, which when you have a spinning black hole, they spin pretty fast, and it's like a nozzle. The pole is like a nozzle. That's where there's not much sideways motion. So it's the only available exit. And you've got all the stuff from all around the disk and everywhere else trying to get out through this hole. And so it just comes out like a water out of a nozzle. It forces it all to go down through a narrow jet.
And usually it's bilateral and it comes out on the other side too, but we're not seeing that part.
Oh. That's because here it ran into dust and debris and it's making this real obvious bow shock. But you can't see the beam of stuff coming out either way, at least not in these wavelengths.
No, it's not an accretion disk. There might be one around it though,
There's
right?
probably one
Yes.
around it, yes, way in there.
And that stuff is the same stuff you'd find in a nebula?
This is a nebula, and you
That
found
is a
a
nebula.
nebula.
Nebula just means cloud, Ronnie.
Yeah.
Okay. Is it going to keep going?
It's trying to. If the stuff gets thick enough, that'll stop it.
Won't stop and come back.
No.
The stuff is shooting out pretty fast. I don't think it's going to rebound.
Why can't we see the bottom half?
It's not running into anything, and it's not bright enough by itself.
And it may be pointed away from us slightly.
Yeah.
And you can see all this dark stuff. That's dark clouds that may be blocking our view of it.
But is the black hole part of a binary with another star, or is it its
Yes,
own?
yes. That's why we know it's there. It's accreting stuff off the companion and giving off X-rays. So Cygnus X1, it's a powerful X-ray source.
Yeah.
Oh,
Since the jet itself isn't visible in this image, but you can see the bow shock, the bluish umbrella-like shape at the top center of the image, that is produced when gas in the jet collides with other gases in the nebula. The bright orange gas on the left edge of the picture is the emission nebula called Sharple's 101, which is the Tulip Nebula.
okay. And Ronnie, this is a question I get at star parties a lot. What's a nebula?
Mhm.
And then I think nebula is a Latin word that translates into cloud.
Yes, it is.
Right.
Each
The
time
image was-
you tell us one of those questions, are you going to throw on the screen behind you a picture of it?
I'm going to blow it up.
Oh,
Step
don't
back.
don't blow up Farron Hall. The museum might be upset about it.
The image, and this is important for the next session, the image was generated with observations in hydrogen alpha and sulfur. And so if it's emitting in those bands, then you'll see it. If not, you won't.
Oh, wow. Wow.
Now, in color images of the, we're going to discuss that real briefly in 3 charts. This is the human eye. This is one of our typical Astro cameras, a KAF 8300, very common. And this is a chart explaining nebula colors. But before we get to that, we have to define what nebula colors are. Now, this is the human eye. This is this is the effect. These are our 3 chemicals that are in our eye that are sensitive to light. This is our long wavelength here. This is our short wave, medium wave, and the green. And these are all cone shells. These are they sensitive to color, and they have to have a certain level of color before they'll trigger. They don't trigger on faint light. That's your rods around the edge, and that's why averted vision works so well. But this whole curve here is the equivalent of what we think we see in our eyes, how these 3 are interpreted to be what the human eye sees as white light. It's all these together. Now, if you look in the sky and you see something up there, we can't see colors. There's no way of seeing colors, but we can take exposures that mimic these 3 bands. And our typical silicon is like this. This is, we're out here. This is about the cut on. This is ultraviolet. This is actually infrared out here. Silicon is sensitive to that. That's why if you use a DSLR, a regular camera like your cell phone, you have to have an infrared filter in. Otherwise, you won't be able to get a good focus because this stuff will hit. You're sensitive to it. Your camera is, but it will be out of focus. So you need to block that. Otherwise, you get fuzzballs around everything. So this is how in the camera, the red cell, and this is for a Bayer filter camera. That is, it's not having a red filter, a blue filter, or a green filter over the whole camera entrance. You can do that too, but this is for a Bayer filter where each little pixel has a certain color permanently affixed to it. And that's why there's 2 greens here. One, the light green is a green in a red spot, and the other one is a green, a green in a blue spot, if I remember right. And so you can just forget that there's 2 of these for your eye. But it puts together a reasonable, if you leave it undoctored, it puts together a reasonable approximation of our eye's color sensitivity. And you'll see that if you're taking a picture of a soccer game during the day with your kids in it, it'll look normal to you. But when you're looking at very faint light, you can't do that. So it depends on how you mix and match these colors to get together to get a true color. The trick is that most of our nebula pictures are taken by scientific cameras, such as the James Webb Space Telescope or the Hubble or the Spitz instrument or the, Nancy Grace Roman telescope. These things, they're interested in specific compositions, specific chemicals that do not correspond to these, how the human eye sees light. So if you want to make an astro image that looks like it would be correct if it were just brighter, that's what's called true color. But that's debated quite a bit because they claim there is no true color because you can't stimulate the eye with these colors. It reacts differently to brightness.
So in this, Jerry, would about 800, 825, what is that, nanometers? Would that be where they kind of intersect?
Nanometers. This would be 7,500 angstroms if you're calibrated in that. So right in here is H alpha, hydrogen alpha.
Yes, yes.
So a lot of this stuff, and right about in here, your infrared cuts in.
Huh.
So really looking, the camera cuts out all this stuff. But when you put it together and you have manual control of it, or if you do it in one of the automatic programs, you hope they do it the way you want it done, but they don't necessarily do it. Then you get these colors, and these are in what's called true colors. That is, an attempt was made to generate red, blue, and green as the eye would see it, and then they're put together. If you want to do that now, all the data, image data from all of our instruments, James Webb and Hubble and et cetera, those are all in public domain for the US stuff. For European stuff, it pretty much is too. You can download it there. It's usually in a format called FITS, F-I-T-S, and there is a free program that you can download called FITS Liberator, and you can collect this data, put it on your computer, and then play with it with your processing information. But somehow you've got to put together the colors as the human eye sees.
Are the FITS files really large, Jerry?
It depends on how many pixels there is in there. The advantage of a FITS file is they have a gigantic header. This header is accessible by the viewer, and you can change readings in it.
Yeah, for example, Tim, my occultation camera stores its images in a data set similar to FITS. It's readily convertible to FITS, and it has this big header, and it tells you what camera you're using, what telescope you're using, what your exposure is, any filters that you have on.
Right.
So it's called Flexible Image Transport System, FITS, and it was made for astronomy and for sharing images.
Right.
Okay, and a header is what?
Well, that's data that's attached to the image data.
To the beginning of the file, right?
Well, you can put it wherever you want as long as it's in a consistent place.
If you have a program that can read FITS, which most can, you have view header, and it'll take away the picture, and it'll just show you a great big thing that looks like an Excel spreadsheet with all the topics and all the values in it.
Yeah.
So
okay, I'll get there someday.
One of the tricks that I ran into is if you're taking it with a DSLR, then some programs like Nebulosity 4, which used to be common among amateurs, it will not record that it was taken on a DSLR, even though you had to put that information in there. So when you go to debayer, the debayer stuff won't come up. You have to go into the FITS header, change the word from none for filter to Bayer, and then it will decode. But some of the things you can't, some of the software won't let you alter the FITS. So I have to go to a special program to do that. It's very irritating.
Boy, what you guys do is so complicated that's
It's
why
not
I
really,
think I'm so.
it's not.
Yeah.
You just got to do it once and then you get so mad at it. I mean, you'll definitely remember what goes on. So anyway, here's the bottom line. If you see blue in a nebula, it's hot young stars shining by reflected starlight. Red, excuse me, I may be being paged here. It's my dentist, he can wait. So, this is red. This is where the hydrogen is something shining on the nebula, but it's not reflecting off the head nebula. It's exciting the nebula, the gases, and now they're glowing by their own light. Green is for hydrogen. The glow is for hydrogen alpha. If it's green, it's glowing as
Option 3.
that should be down here. But anyway, ionized oxygen, and if you see it in yellow, it's a mix of hydrogen, sulfur, and dust.
Huh.
And this is by excited emissions.
Now,
So
Jerry, is this when we see an astro image and we see these colors, do they respond? Do they?
now you have no idea what the guy assigned as red, blue, green, or yellow.
Yep.
You
That's
have
what I was
no
going to
idea.
ask.
You just hope that he did it right.
Okay.
See it.
Okay.
And they'll say true color or something, or if you know them, for example, the infrared, there are so many bands out in the infrared in JWST that they tell you what the filters are they use, and then you can see the colors, and then you can put those together to make it whatever color you want.
Good grief. Wow.
My understanding is that if all the colors at once are together, it's white.
If what?
Doesn't the sunlight is white because it's got all the colors in it. Well, I'm thinking that if you saw a nebula that was all white, it's got everything we're seeing here.
Yeah, lots of luck on finding one of those.
Yeah.
No kidding. They don't. Well, all the stars seem to be white.
No.
Oh, that's just because your eye is overloaded. And remember, you're looking at the night sky in black and white vision.
I understand that. That's what I'm
No,
saying.
you wouldn't ask that. There's
Well,
no color.
if we had the ability with our eyes to see infrared and ultraviolet, boy, we'd get a light show, wouldn't we?
It'd probably be very confusing. Not
Really?
much use in those things. See, if you were a vampire and you're out at night and you need to find a human victim, seeing in the infrared would be very helpful.
That's true.
But you don't do that. Mosquitoes do it, and that's why mosquitoes can see out at 11 microns in the far infrared, because you're glowing like a Eat at Joe's sign, except it says bite here.
Yeah.
And rattlesnakes have the same thing. They have two pits on their nose that are infrared sensitive. They don't get an image, but it balances. If one pit is brighter than the other, it'll turn its head that way. So it does its terminal guidance on your heat.
Oh God.
They don't miss.
Yeah, the mosquitoes have this little "Eat it, Chuck's" sign on them.
Yeah.
Well,
I'm a
friend of mine
mosquito
went
magnet.
But what can be confusing about what you just said, Jerry, is that on one end of the spectrum, the color spectrum is your infrared, which is heat. And on the other
Well,
end,
it's long wavelength light. It's not
Yeah.
really heat.
It's not really,
it's not heat. It indicates heat, right?
That's a colloquial generalization. It's not really true.
Okay.
So everybody that has a temperature is emitting radiation at some wavelength.
Primarily.
Yeah.
Right.
Yeah.
Right.
But the nebulae and the stars that are in the blue range are really pretty hot and new, right? Brand new
Right.
and hot.
30 to 60,000 degrees in general.
And the old web won't pick up stuff from them in infrared. It'll all be ultraviolet.
No. They everything radiates over an entire spectrum. It's just what parts are strongest.
Right.
Got it.
And where the peak is. For us, the peak is in the green. That's where our sun emits the most.
Okay,
And
I've
that's
been
where
telling
our
people
eyes
yellow
emit
green,
the
but
most.
Well, yellow green is right, Tim.
Yeah, it's called
Okay.
a Planck curve.
But
So a friend of mine went camping in Alaska and he came back and we said, how was it? And he said, well, one morning I woke up in my sleeping bag and I was tied up in my sleeping bag. And there were two mosquitoes standing at the edge of the tent. And one of them said, shall we eat him here or take him back to the hive? And the other one said, no, if we take him back to the hive, the big guys will take him away from us.
Oh,
The other
God.
one that I heard a lot was from my uncle who lived in Seattle. And he said that one time a mosquito landed at Seattle Tacoma International Airport and they pumped 50 gallons of jet fuel into it before they realized it wasn't an airplane.
Pretty good.
fascinating stuff. But was
But
I
we have
right?
also, go ahead.
Was I right? White is all the colors together?
It's all the visible colors put together by our eye.
By our eye.
The right balance, yes, that's white.
Is our sun a white star or a yellow star? I've been
It's
told
a yellow
both.
star.
It's a yellow star. Okay,
We interpret it as white when we see all the light from it.
got it.
And here's a star chart that will
Your
leave you
favorite-
totally lost trying to find a comet.
Born in hell.
Every time I get one of these, I think, oh, Chuck's not going to like this.
Yeah.
But anyway, this is Comet Tempel 2 that shows the path during July 1 up to 30. You'll notice the benchmarks up here, M72, M73.
Mhm.
Down here is M30.
Right.
And
There you go.
here's
That-
M72, M30, and there's M30. So it's going right down here over
Nice.
July.
Oh,
Now,
shoot.
this is until I learn how to make a curved line on the Sky 6 that doesn't erase when I try and save it. So I've still got something to learn on that. So anyway, Temple 2 is
Slightly angled to the
right
old
there. Earth
plane.
and Temple 2 is just a little farther out. It's only a quarter inch on this scale.
Right. There's the two passages we saw earlier.
Well, that was a different.
That was a different, that was Swift.
Oh, was his Tuttle.
Yeah.
Yeah. The interesting thing is that at this angle and coming at us, its tail looks like two tails.
Mm.
And this amateur astronomer, I think it was amateur, took this picture.
Oh.
Yeah, I think so.
Yeah, it's Chuck Ayub again. And captured on July 11, 2026. Nice capture on the two tails coming out from the comet. And this comet is very well placed. It's up in the night sky,
Mhm.
as you saw in the Finder chart.
Can't see it with the naked eye.
So this is
Not quite.
It's magnitude 9 right now,
Okay.
which is not visible object, but easy object in small scopes. A 6-inch Newtonian, for example, on a dark sky will pick up stars up to 13th magnitude. So that a 6-inch telescope should easily capture this thing. And once you can locate where it is, you'll see the fuzz and it'll work best by averted vision. And it's an easy object for photography.
Mhm.
This is a very nice capture of it by
It is spelled Tempel. Is that two words, two astronomers
No,
put
no,
together?
no.
Not
It's
a-
one guy
One person.
named Temple.
Oh, okay.
it's Comet 10P and then Temple. 10P stands for periodic, and I forget what the 10 is. I guess it's the order in which it was assigned.
The order in which they calculated the orbit for it. Yeah.
Okay.
Well, my understanding, gentlemen, some comets do have two tails, but never in opposite directions. I've never seen
Oh,
one of
this
those.
is just a perspective effect, Ronnie. And it's not so much the tail as also just debris that's been left behind in its orbit.
Yeah.
So it's more like the dust tail.
It's like the zodiacal light, which we see inhabiting the ecliptic of the universe at some angles of sunlight. So some comets appear to have three tails, a ion tail, a dust tail, and then an anti-tail, which is actually a perspective distortion.
Well, given your earlier color charts moments ago, what's the green here?
This is diatomic carbon.
Carbon.
Yeah. But it's a molecule, not just straight atom.
Got to tell you, carbon is a pretty plentiful element, but it's becoming the bad guy, isn't it, in my mind? Because of
Nothing wrong
CO2.
with carbon. It's carbon dioxide that's
I
bad.
know, I know.
Yeah.
Well, we learned a lot, didn't we, Tim?
Boy,
I can't wait for the test.
that's I'm going to try to make that workshop this week because oh, Jerry, I got a question yesterday on my solar scope. It was how do I know for sure that my solar filter is safe? Is there something to measure it with?
Get a little kid you don't like. No.
Lock it up and you're safe.
The is safe. Well, first of all, I'd make sure that it was it has a historic trail that you know everywhere it's been and who's used it or had access to it. You know that they don't tinker with things. They haven't changed the optics a little bit.
Yeah.
I
But
know
just
some
like
are-
say with the Lunt scopes, do they test these and
Yes.
with
Oh
what?
yeah.
Well, their design is, as long as their design is true in that model, that one they didn't make any mistakes, nothing broke before or after it was assembled, you know it's fine.
Okay.
But you can also
I had a customer that
you can
was
also
really
hold-
nervous about using my scope, and I said, no, these are totally safe.
You can also hold your focus and image in it and then hold your palm of your hand at the exit pupil of the scope. If your
Okay.
hand bursts into flame, don't let people
Yeah.
And white light filters like the
Mylar.
well, the
Oh, okay.
Mylar, would get holes in it. That's where you'd have a danger there.
Yeah.
I'm not sure if they expire, but the Inconel ones, the metal on glass,
Yes.
they have usually an expiration date that's something like 10 or 15 years if they've been used pretty commonly in the daytime sky, because they eventually deteriorate.
Yeah, I have one on glass that I got a long time ago, and it's still really good.
Yeah,
But-
but you haven't been doing a lot of solar
No.
observing with it. Yeah.
No.
I
I'd
didn't know
still,
the metal on glass deteriorated. I wonder what the mechanism is.
yeah, I don't know what it is, but I remember reading somewhere that, they sort of give you a hint of an expiration date.
Huh.
And that might just be lawyerly, overreaction, but I'd still be careful with it.
Yeah, it's always good to be careful. Never leave a telescope set up and no one manning it.
Yeah.
Oh, there you go. Well, look, gentlemen, I think we've run out of time. In fact, we've gone over. We love this stuff. We'll be back again on Monday. Don't forget to make plans in 2 weeks on Friday the 8th to see Jerry's speech at Farron Hall. And tell your friends about us. Number 283 will be next week, Monday morning at 11. So long for the
Thank you,
SBAU
Jerry.
Astro Hour, or as we
Thanks,
call it, how do we say goodbye?
Hasta nebula.
Live long and prosper.